హలో ఓపెన్ ఓపెన్ కాదు కదా చూడు ఓకేనా
सर्वदा वक्रतुंड महाकाय सूर्यकोटि समप्रभ निर्विघ्नं कुरु मे देव सर्वकार्येषु सर्वदा। सूर्यकोटि समप्रभ निर्विघ्नं कुरु मे देव सर्वकार्येषु सर्वदा। वक्रतुंड महाकाय सूर्यकोटि समप्रभ निर्विघ्नं कुरु मे देव सर्वकार्येषु सर्वदा। वक्रतुंड महाकाय सूर्यकोटि समप्रभ निर्विघ्नं कुरु मे देव सर्वकार्येषु सर्वदा। वक्रतुंड महाकाय सूर्य।
Good morning, ladies and gentlemen. I am Professor Shrikant Korla, one of the organizing secretaries for Incam 2024. On behalf of the Indian Society of Applied Mechanics and Organizing Committee, I warmly welcome you to the inaugural session of the 6th Indian Conference on Applied Mechanics, being held here at the prestigious National Institute of Technology, Warangal, from the 12th to 14th of July 2024. It is indeed an honor to have all of you here today. The conference brings together some of the brightest minds, leading experts and scholars in the field of applied mechanics. Now it gives me immense pleasure to introduce our esteemed dignitaries, chief guests of the inaugural session, Professor Lakshman Rao, Professor in Applied Mechanics at IIT Madras, Professor J.N. Reddy, Distinguished Professor in Mechanical Engineering at Texas A&M University, Professor A.M. Rajendran, Professor of Mechanical Engineering at University of Mississippi, Professor Vidyadhar Subudhi, our beloved Director of NIT Warangal. Now I invite all the dignitaries onto the dais. I request our organizing secretary and my colleague, Professor Tejasvi, to accompany them onto the dais. Please. I request everyone to stand for the national song.
Vande Mataram, Vande Mataram, Sujalam Sukhalam, Malayaja Sheetalam, Sasya Shyamalam Mataram, Vande Mataram, Shubhra Jyotsna Pulakitayamini, Pullakusumita Drumadala Shobhini, Suhasini Sumadhura Bhashini, Sukhadam Varadam Mataram, Vande Mataram, Vande Mataram.
Please be seated. I would now like to request that all the dignitaries on the dais please come forward for the ceremonial lighting of lamp. Students.
असतो मा सद्गमय तमसो मा ज्योतिर्गमय मृत्योर्मा
Request HODs to join, please.
गमय
Organizing department HODs, please join.
असतो मा सद्गमय तमसो मा ज्योतिर्गमय मृत्योर्मा मृतं गमय ॐ शान्ति 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 असतो मा सद्गमय तमसो मा ज्योतिर्गमय मृत्योर्मा मृतं गमय ॐ शान्ति शान्ति असतो मा सद्गमय
Thank you, sir. Now I invite Professor Lakshman Rao, the President of Indian Society for Applied Mechanics, and also a professor in Applied Mechanics at Indian Institute of Technology, Madras, PhD from MIT, and master's and bachelor's degrees from IIT Madras. And with over 2 decades of impactful research and teaching, Professor Rao has made significant contributions to structural engineering and sustainable construction practices. As we gather here for Incam 2024, we are honored to have Professor Rao with us to share his valuable insights. Please join me in welcoming Professor Lakshman Rao to give a presidential address.
Namaste. A very warm welcome to all of you. I would like to spend a few minutes taking you all through the journey of this conference called Incam. What started as an attempt to bring together the departments of applied mechanics in the country, as well as others who are associated with the broad definition of applied mechanics, together at least at frequent intervals to discuss research ideas and path for future. In a humble way, it started in 2013 at IIT Madras. So the next conference was also held in IIT Delhi, which is another applied mechanics department in 2015. And around that time, idea crystallized that it's good to have a society that coordinates these meets. And initial feedback seems to be that these conferences are serving the purpose of bringing people together and having insightful discussions. And subsequently, we had a conference in 2017 in Allahabad, and then a small conference in Goa, and later in IISc Bangalore. And we had a virtual meet during the COVID times, and later followed by Jamshedpur, and then now we are here. So I think over the years, there is at least some set of people who look forward to this conference and they are benefited from it. And I think we are also in a journey to discover what we can all do together. In my opinion, I think we are also trying to discover a Bharatiyata in the research that we do and so on. So what do you mean by this Bharatiyata? See, the laws of Newton or laws of Maxwell are have been there for time immemorial. In fact, they were there even before Newton and Maxwell called them as laws. And there's no time and geographical boundary for these laws. But their manifestations at different times, at different places, has a uniqueness. And that is something that brings out the variety in the discovery of these laws and its applications in various backgrounds. And therefore, what I mean by Bharatiyata means that there is some flavor to the way we look at applied mechanics for specific problems perhaps in Warangal, which is different from the way we may look at it in Texas, Austin. So there is, debate. You say that laws are universal, but I say that manifestation of the laws are definitely have their variety, and that should be encouraged. And therefore, the encouragement of the manifestation of these laws or interpretation of these laws or discovering new things is what we are trying to encourage staying here in India. And I'm glad that many others are also participating in this discovery and the journey that we have started with. For example, one of the things, we are definitely keeping open all the traditional fields of solids, fluids, biomedical design, and so on. And people are coming and contributing in those directions. And apart from that, we are also trying in our humble way to discover what are the relevant problems that we can work on that may solve the local problems as well. And therefore, that is something, it's an exercise that has to be done again and again, and maybe there is some value to it. I just go back to the way I was asked to define a PhD problem way back at MIT. He says, my advisor told me, the roofs are leaking and please make a PhD topic out of it. So which roof is leaking? What type of leakages that are happening in Massachusetts is definitely different from the type of leakages that you will find in Warangal here. And therefore, the same problem definition can have different interpretations and different manifestations. And that should be actively done by all of us in our own local setting. Is a discovery which but some people agree with it, some people may not agree with it, and so on. But that line of thinking also is what we are trying to encourage here. So in that direction, we are also having small get-togethers, some workshops, etc., on rural applications of applied mechanics. We started one workshop in Sevagram, then we had a small gathering in Jamshedpur. We had a special workshop in Bhopal where we tried to get together all academicians to see what type of relevant courses can be done so as to excite students to at least get exposed to relevant problems that are there in our own communities around. So that was successful, and we have documented all that also in our website and so on. That's one line of thinking. And we were also trying to focus our attention on education in general. One workshop in that direction took place in IIT Madras in 2018, where we were trying to see what can be the contours of a unique dimension that we can give on the relevance of mechanics and its adaptation to new situations in various in the current context, especially what can be offered by applied mechanics department. Fortunately, we distributed our minutes of the meeting to all directors and so on. And somewhere by good fortune, the director of IIT Delhi took it seriously with the Department of Applied Mechanics in Delhi, and they came up with the new formula called Engineering and Computational Mechanics. So the first BTech program in that direction got started in IIT Delhi, and their graduates have come out in this year. And inspired by that, at least 3 other NITs have started the same program in their own manifest small things in their own institution. One is NIT Allahabad, the other is in Jamshedpur, the other is in Bhopal. Now in the workshop, in the one-day workshop that happened just last Monday in Delhi, we invited the chairman of AICTE to inaugurate the function, and he was very excited about it, and he says that Apart from NITs and and IIT, there are many more engineering colleges which are looking for ideas where they can train their students. And when the circuit people are starting at least 100 different BTech programs in VLSI, there's no reason why you should not start one on engineering and computational mechanics across the country. And that gave us a lot of encouragement. And I am sure that with the pursuance of the society and its background, many more such things will be starting across the country. See, the whole point that this community should always contemplate is that mechanics is still relevant and it's very useful. And in the passage of time, with the onslaught, I would call it as onslaught of machine learning and other things, people pursue it apologetically. And I think that the responsibility to change that is solely rests on people like us. I mean, all academicians and industrialists and so on. And that is where I think we have played an important role. We asked some of the students who are graduating from this as to why they chose this program, the BTech people in IIT Delhi. And they said that they were all excited with physics and mechanics. And they were also interested in computation. And this is a program which gives a good insight with both of them. And then it will also link them to some applications. And a few companies also said that it's a very good program to start with. So perhaps we are also discovering new programs which are relevant to the society. And another thing that the society is also focusing on today is to transmit the excitement of research right down to the undergraduate programs and somehow get them involved in exciting research that we do at an early stage. So in this year's conference, we announced a special undergraduate research program presentations where the main author is the undergraduate student along with some co-authors and so on, and we have also announced some special prizes for it. To our surprise, there were at least 20 entries to it where for a first-time entry into this program. I'm very happy about it, and I'm sure we can engage undergraduates much more in future. And that's a direction in which that many of us should also look into, primarily because the IIT systems as well as the NIT systems do select candidates with the best brains, and they can motivate them properly. And the motivating them properly rests on faculty and teachers like us. So this is a broad background of where we are today and the way we are trying to look. In this year's symposium, another experiment, in this year's conference, another experiment is being tried out in the form of mini symposia. It's a new experiment for us, but many conferences are also doing it across the world. So we announced the possibility of a mini symposium on specific themes where coordinators can bring people on those themes across and so on. So this year we have at least 7 different themes. Some of them are on traditional tracks like large deformation of structures and large and multi-scale modeling and composites and blast and so on. And a few of them are on what I would call as unconventional topics. We have one on mechanics of sport, we have one on frugal initiatives in rural India, and another one on characterization and monitoring of traditional Indian practices. So I think these discussions that we are going to have in these special themes will help the researchers to identifying new paths in which concentrated research where mechanics and scientific community can contribute to many problems that are being faced in the society. So we are getting some confluence of Ayurvedic doctors and scientists here, and similarly some people from sports as well as mechanics people here in these media symposiums. And I think it's an exciting discovery, and wherever possible, I request all of you to participate in these mini symposium as well. I am very glad. And another thing that I would like to mention is that all conferences would like to have a journal outlet. And the journal outlet is something that we keep searching all along whenever we hold a conference. Sometimes we are successful, sometimes we are not. Many Indian journals, the popular journals like Sadhana and Journal of Structural Engineering, simply turned down our whenever we try to offer. In this background, I am so glad that the journal that has been started by Professor Reddy in the form of International Journal of Computational Methods in Engineering Science has come up with offering at least 2 special issues from the proceedings of this conference, and I really want to congratulate Professor Reddy for making this happen. So that's another thing. I mean, publishing is an important thing, and I think Indian community is not owning up the responsibility of publishing. It is looking to our circuit friends who look for IEEE as an outlet for their journal publication. And I think not all international journals are doing things correctly. I know of international journals who simply drag on publication with 1 reviewer, whereas we in India at least do have 3 reviewers for some journals and so on. So there's much more that needs to be done to encourage journal publication within the country. I hope the society will be able to address it also in future. So with these few words, I would like to congratulate all of you for choosing to attend this conference, especially our international guests, and also thank the NIT Warangal setup for coming up enthusiastically to hold this conference at this time. Thank you very much, and Jai Hind. Thank you.
Thank you, Professor Lakshman Rao. Now I request our other organizing secretary, Professor Tejasvi, to give the address for regarding Incam 2024.
Good morning, ladies and gentlemen. The 6th Indian Conference on Applied Mechanics, Incam 2024, at the National Institute of Technology, Warangal, aims to convene researchers, scientists, engineers, and technocrats to advance the field of applied mechanics. This conference serves as a platform for global specialists to present cutting-edge research, fostering a collaborative environment for knowledge exchange. Incam 2024 features 3 distinguished plenary talks by Professor Jain Reddy, Professor Rajendran, and Professor Trilochan Sastry. Over 200 papers underwent rigorous double-blind review, ensuring high-quality contributions that have been selected for oral presentation after authors incorporated reviewers' suggestions. The lineup of the conference includes 2 pre-conference workshops and 6 major tracks in solid mechanics, fluid mechanics, biomechanics and biomedical engineering, design engineering, composites and advanced materials, and thermal engineering. A novel addition to the format are 7 mini symposia focusing on specific topics such as characterization and monitoring techniques in traditional medicine practice, frugal initiatives for rural areas, mechanics of force, blast, shock and impact dynamics, multi-scale modeling of polycrystalline materials, mechanics of highly deformable structures, modeling of inelastic deformation and fracture in composites and heterogeneous materials. In all, 34 invited speakers will share their expertise with attendees. Additionally, 21 submissions for special undergraduate research presentations will highlight young talent in the field. The conference also offers yoga sessions and Sattvic Ahar. Yesterday, 2 pre-conference workshops were conducted. One was ANSYS Theory and Practice by our own faculty, Professor Jay Krishna, Professor Rani, and Professor Ajay Patel. The second one was on Joy of Writing by Professor Daniel Raj from IIT Madras and our faculty, Professor Vishwanathan. The full papers from this conference will be published online in a global lecture series by Springer, ensuring rapid dissemination and global reach, thereby enhancing the conference's impact within the research community. Selected papers among these are proposed to be submitted for journals. The organizers express gratitude to all authors for their contributions and to reviewers for their invaluable feedback, which has been instrumental in shaping the conference's success. The collaboration among 3 departments, civil engineering, mathematics, and mechanical engineering, has been pivotal in organizing Incam 2024. Established in 1959, the Civil Engineering Department at NIT Warangal has 44 faculty and is renowned for academic excellence and extensive research and consultancy work supported by various government bodies and private enterprises. The department offers 1 BTech program in civil engineering and 8 PG programs, as well as a quality improvement program in PhD since 1978. The mathematics department, also founded in 1959, excels in applied mathematical sciences, offering diverse educational programs and research opportunities. The department offers PhD degree, 2-year MSc Applied Mathematics, MSc Mathematics with Scientific Computing, 5-year integrated MSc courses, 4-year BTech in Mathematics Computing, and service courses, institute level PhD and minor level courses. Meanwhile, the Mechanical Engineering Department, since its inception also in 1959, has 49 faculty at the forefront of education and research with 1 BTech and 7 specialized MTech programs, PhD programs, and very robust research facilities. Our acknowledgements extend to the Institute's leadership, including the Director, Deans, Registrar, Department Heads, and senior professors whose support has been integral. Special recognition is given to the research scholars from these 3 departments for their contributions and efforts. The organizers extend their thanks to all involved in planning and executing the conference, including experts, delegates, and participants, without whom this event would not have been possible. Any conference of this nature and magnitude will have shortcomings. No plan survives contact with reality. Please bring any inconveniences to our notice. Our team will endeavor to make your stay comfortable. In conclusion, Incam 2024 promises enriching discussions and interactions among participants and eminent researchers in applied mechanics, while ensuring a healthy, productive, and memorable experience for all. So welcome to NIT Warangal. Thank you.
Thank you, Professor Tejasvi. Now it's my great honor to introduce our distinguished guest for the Incam 2024 conference, Professor Jayan Reddy, a distinguished professor at the Texas A&M University. And Professor Reddy is a world-renowned expert in applied mechanics and computational mechanics. His pioneering work on the finite element method and plate theories has profoundly impacted engineering education and practice. A fellow of ASME, AIA, AM, and the recipient of numerous prestigious awards, Professor Reddy's contribution continued to inspire and advance the field. He's also delivering a plenary lecture immediately after this inaugural. So please join me in welcoming the Professor Jayan Reddy for his brief inaugural address. Thank you. Nice speaking to you, sir, after long.
Very good morning to you. So I was looking at the program, and we have only 1 minute to complete this program. So we are already running late. So all I want to say, hearty welcome to this 6th conference on computational mechanics. And I admire and commend the organizers, including Professor Lakshmana Rao and also Tejasvi, Professor Tejasvi. And I look forward to having an informal discussion. We are returning to BC, before COVID, right? So without seeing each other, looking into the eyes, I would not know if you are following my lecture or conversation. So physical meeting is a necessary to exchange of ideas. And the world, it becomes better only through innovations, however small it is. We have to take pride in what we do. So with those few words, thank you for inviting me to be here, and I'm looking forward to having chat with you during next couple of days. Thank you.
Thank you, Professor Reddy. Please be seated. It's my pleasure to introduce our esteemed guest for the Incam 2024 conference, Professor A.M. Rajendran, a leading authority in material science and computational mechanics. Professor Rajendran's groundbreaking research in dynamic material behavior and advanced computational modeling has significantly advanced our understanding in these fields. We are honored to have him share his insights and expertise with us during his plenary talk tomorrow. So for now, please join me in welcoming Professor A.M. Rajendran for his brief inaugural address.
Good morning, dear Incam participants, the organizers, distinguished visitors, distinguished speakers, and Honorable NIT Director, Professor Subudhi. It's an honor to be here to speak to you now and again tomorrow about applied mechanics. And, my suggestion to you is that applied mechanics is, was an important field, is an important field, will be an important field. It crosses across all disciplines. So the one thing, the future for applied mechanics, the change it's going to make by using like machine learning and artificial intelligence, the mechanics community will contribute, like in terms of innovation and invention, not only in engineering mechanics, but in biomechanics and all other related field. I am very happy to be here, and I'm not new here, Many of you may not know that I came here in 2018, I think, for 2 weeks to give a course on under Gyan program, and I really enjoyed my stay and the culture in Warangal and some of the important places that I visited left a fantastic impression and memory in my heart. And I'm so happy to be back here, and I thank the organizers for the opportunity given to me to speak to you. And I'm sure you are going to learn a lot next 2-3 days. And people, especially PhD students, and they should really pay attention to a lot of the new theories and new state-of-the-art computational modeling, and you should master them and then come up with an excellent thesis. I wish you all good luck, and thank you.
Thank you, Professor Rajendran. Now I request all the dignitaries on the dais to release the book of abstracts. Thank you, sirs. Now I request our beloved director, Professor Subudhi, to address the gathering. Sir, please.
A very good morning to all. So it is my distinct pleasure in inviting the distinguished guest for this conference and the delegates to our campus. I'm glad that the most distinguished contributors in the area of applied mechanics are here in our campus. So I'm like Professor Reddy from Texas A&M University, US, and Professor Rajendran from University of Mississippi, US, and also very distinguished professor of IIT Madras, Professor Rao, and my colleagues from 3 different departments, particularly the organizers, and Professor Tejasvi, Professor Rani, Professor Kurla, Professor Patel, and the 3 heads, Civil Mechanical Mathematics, Professor Reddy, Professor Kumar, and Professor Banerjee Babu. So it is a truly demanding situation that we fulfilled. Actually, needless to mention, India has mandated now NEP, National Education Policy, where one of the mandates is to adopt the multidisciplinary approach in both teaching and research. And therefore, this conference is one of the outcome of this endeavor towards meeting this multidisciplinary approach in contributing applied mechanics in both teaching as well as in research. And I'm glad that IIT Delhi and 3 of the NITs are thinking in this direction to offer the BTech programs in applied mechanics. And I think this applied mechanics not only has a big kind of acceptance in terms of the academia, fraternity, but also from the industry as well. So therefore, I believe and it is a series conference, so I always feel very impressed in organizing the series conferences, because it basically the baton shifts from one inch to the other, but the objectives are multiplying manifold from one to other. And in this process, my only observation here, the industry participation should be more emphasized. Maybe there is exclusive session from the industry participation, and there could be one addition like the young professionals contribution. So maybe looking at the hall, I could see the average age group of the audience is around 30 to 35. So therefore, this is definitely will give a more momentum to this kind of conference. So the organizer for the last couple of days are coming to me and discussing how they will be organizing and all that. I'm quite glad they're meticulously planning for the SEM. And therefore, 200 publication, the responses from 200 contributors is definitely very remarkable. And also the institute like IIT Madras and many other institutes are participating in this conference. So this is truly accepted in the society in terms of its recognition. And the outcome of the conference, I believe, will be published in good journals and also some media where it will reach out to many of the peers in the society of applied mechanics. So I'm not an expert in this area, so therefore I am afraid to say something on applied mechanics in front of all these distinguished contributors in this area. So as the director of the institute, I take this pride that NIT Warangal is joining hands in the endeavor of this applied mechanics fraternity to give a new momentum in the future years to come. And I wish this conference a grand success and all the delegates to have a wonderful stay and wonderful discussions for their future research agenda. Thank you very much.
Thank you, sir. Now I request our director and our coordinator, and also I request our head of the departments of the organizing departments to join to felicitate our distinguished guests and the President ISAM. Please. చెయ్యి తీసుకొచ్చి. So thank you, sir. Now, before we go for vote of thanks, there is a small announcement. We have a Alvar Memorial, Professor R.S. Alvar Memorial Plenary Lecture by Professor J.N. Reddy immediately after the inaugural. And then after that, we'll go for a photo session in high tea. Just this is an announcement. So all of you please be here for the plenary talk after this. Now I request Professor Hari Krishna for the vote of thanks.
Dignitaries on the dais and off the dais, experts from all over the world to deliver the different memorial and invited lectures, along with participants of this conference, invitees, press media, student volunteers, ladies and gentlemen. A very good morning to all. I feel honored and privileged to be standing here on behalf of Organizing Committee of Incam 2024 to convey the gratitude in the form of vote of thanks. On behalf of Organizing Committee of Incam 2024 and NIT Warangal, I extend a hearty vote of thanks to our distinguished guest, Professor Sri Lakshman Rao Garu, Professor of Applied Mechanics, IIT Madras, Chennai, and the President of Indian Society for Applied Mechanics. Sir, today we had an opportunity to hear your thoughts on various important aspects like the starting of this conference from IIT Madras from 2013 and at various primary institutes in India. And you were mentioning about journey to discover what we can do together. That's very important. And bring Bharatiyata together, Bharatiyata along with loss of applied mechanics, etc. It's a great insight you have mentioned about PhD program at MIT to think of roof leakages. As a civil engineer, I appreciate this. And it's great to hear that one. And we'll surely be going to encourage all this in your future events also, sir. And the other two distinguished guests, Professor J.N. Reddy, the distinguished professor at Texas A&M USA, and Professor A.M. Rajendran, the chair and distinguished professor at University of Mississippi USA, deserves a special recognition for accepting our invitation and being here with us to give their address to the participants of the conference. Our beloved director, Professor Bidhyadhar Subuddhi, deserves special thanks for his constant support and guidance. Sir has taken a lot of pains in guiding us in various aspects and has consistently put out a great deal of effort in ensuring that every participant of this conference will feel an excellent time, ambience, and lovely aroma of this wonderful campus, in addition to the enriching technical sessions. Sir, you have always been generous in giving your time to discuss any important issues related to the smooth conducting of this conference. Thank you, sir. I would be falling short of responsibility if I did not express my gratitude to the administration, especially the Registrar Professor N.V. Uma Mahesh, along with all other officers of this campus who have supported us in all possible ways. Conducting any conference needs good financial assistance, and luckily, we had good response in this direction from different sectors. In this regard, I wish to express my special thanks to the sponsors like Dr. Athavan Karunakaran, the gold sponsors, Boxer, Canara Bank, Life Corporation of India, the silver sponsors, Comsol, Kotak Mahindra Bank, the copper sponsors, and Kaizen Technologies and BSST India, the bronze sponsors for their financial supports. And friends, for this type of mega conference, it's not something that happens overnight. Months ago, the wheels for this conference began to turn. It necessitates forethought and keen eye on in all details of these aspects. I wish to express my heartfelt thanks to the organizing secretaries, Professor Tejasvi, Professor Rani, Professor Srikant, and Professor Ajay. These four people acted like four wheels of the vehicle and rendered a lot of dedicated efforts in making this conference a reality today. In addition, we have been lucky enough to have the support of team of proactive and dedicated members of institute personnel, both faculty and students, who are experts in their field. I am at loss for words to express my gratitude for their participation and willingness to do things outside of their comfort zones. I wish to thank the three main pillars who have made this conference a reality. The Royal Civil Engineering headed by Professor Venkat Reddy, the Majestic Mathematics headed by Banerjee Babu, and the Mighty Mechanical headed by Professor Ravi Kumar. I extend my heartfelt thanks to all the chairmen, members of different committees of this conference for their relentless efforts in making the arrangements of this conference. Most importantly, the main strength for conducting this type of mega conference could be derived from our young student friends, the research scholars, and the postgraduates of different departments, along with MSc students of mathematics, who helped us in many ways, needs a great round of appreciation. I wish to thank the Professor in charge Media Public Relations, Professor Rahul, Chief Warden, Professor Abdul Azim, Professor in charge Guest House Sanjit Biswas, Professor in charge of ALS in Seminar Hall, Professor Anjaneyulu, for their cooperation in making these arrangements of this conference. I wish to give an applause and heartfelt appreciation to all those participants who traveled from different places of the world and the countries amidst of hectic travel for the sake of participating in this 6th Indian Conference on Applied Mechanics to be conducted at NIT Warangal and make it as a grand success. I can assure you, friends, and ensure you also that the organizing secretaries have made all possible options like yoga, as mentioned by one of the organizing secretary, in the morning, Satvik Ahar, in addition to the normal food, along with good cultural program, so that you will surely remember this conference for a quite good time as one of the best ones. As some of you might have correctly heard what I mentioned just now, one of the specialties of this conference is you will be given Satvik Bhojan, which will help you in your wellness and well-being. As rightly mentioned by some saintly gurus, the food we eat influences our thought processes and nature and vice versa. The Chandogya Upanishad emphasizes on eating Satvik Bhojan, since eating such foods purifies our mind and results in our inculcating pure consciousness. I wish to thank from the core of my heart the great visionary thought by Professor Lakshman Rao Garu, the president of ISAM, for suggesting to have this Satvik Ahar during this conference as an option for the participants. Sir, we have, as per your suggestion, we have been made arrangements, and as mentioned in the holy scriptures like Bhagavad Gita, that aharastvapti sarvasva trivido bhavati priya, meaning that even the food a person prefers is of three kinds, according to their natures, the modes of nature, Satvik, Rajasic, and Tamasic. Hope your idea of ahara suddhau sattva suddhihi will result in making the people of this conference with pure minds, along with having a simple and comfortable living here and thereafter. Finally, I would like to convey my gratitude to everyone here for taking time to join us today in the inaugural of this prestigious conference, which is being held at Premier Institute of NIT Warangal, and for assisting us in making this event a huge success. Thank you, one and all. And lastly, as Professor Srikant has mentioned, after the national anthem, we will remain here only for the most awaited Alvar Memorial Plenary Lectures by Professor Reddy Garu, and which will be followed by a photograph and plantation, along with tea and snacks being served at the foyer of the hall. Thank you, one and all. Thank you very much.
Thank you, Professor Harikrishna. Now, let us all rise for the national anthem.
जनगण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे
Please be seated. Okay, Professor Tejasvi, you can take them. So now there is a R.S. Alvar Memorial Lecture by Professor Jayan Reddy. The last student of Professor R.S. Alvar, Professor Challapati, is there online. Yeah, so he's available now on the online on Google Meet. So he will introduce about this, and then the program goes on. Thank you. So I request the student coordinator.
Yeah, so good morning to all of you. And I would like to thank organizers for this invitation. I feel it's a great opportunity for me to be with you and share something about my professor, Dr. R.S. Alvar. And before that, I just want to say about Dr. Jayan Reddy. I know I saw him first time in 1985 in IIT Bombay when Tarun Kant organized an international conference on computational mechanics. In fact, I don't know whether remember myself, B.K. Datta went there, invited him for BRC to give us special lectures. At that time, he was with Dr. Warden and Belitsko, if I remember correctly, even Zenkovich. So he gave a series of talks. That is 1985 on occasion. And afterwards, when Cement was organized by Dr. Lakshman Rao Alvar and R.S. Alvar's, Lakshman Rao and R.S. Alvar's memorial, this thing, he came to IIT Madras, and I invited him to IGCAR Kalpakam, and he gave a talk, special talk on final method, along with Dr. Rajagopal. These two occasions I would like to mention here before I start with talking about Dr. R.S. Alvar. I know Dr. Alvar's quite long period. From 1979, my interaction started. Then it went till his last moments. So initially, as a MTech student, I was there engineering mechanics. He took a subject of engineering mechanics, this thing, theory of velocity and experimental mechanics. The novel characters I bring during his teaching style is very unique and not based on the book alone. He comes and induces the people to learn, particularly for experimental mechanics. He was doing some collaborative project for Standard Motors. So the chassis analysis is done by photoelastic modeling. And the entire subject of experimental mechanics he taught in the laboratory where I think many people remember Thomas. And he taught for all the MTech students based on the practically how he does strain gauging, for signal processing, all the things with the whole subject he taught only based on the collaborative project. So it has gone in our mind. I mean, it's excellent way of teaching. And regarding theory of velocity, we always remember that Timson and Young, the book Theory of Basic Theory of Velocity, his name we found several places. Timson mentioned R.S. Alvar's references. You will find a small slant letters. See, he is such an eminent person of those period. Then afterwards, my doctorate work among 10 doctorate students, probably I was the last student. That too, last phase of my doctorate completed when he was on long leave. The special leave was given by IIT, considering his based on his health ground. And that period, he restricted the entire movement between his house and the library and his chamber at Applied Mechanics Department where we are there. So this MSB, it is there in MSB. So these places only our movements were there. That time I got a very intimate interaction on technical ground. For example, he used to take me. Why I'm telling me means it's a case study. You take as a case study his characters, you please try to understand, not myself. So during that period, he from the house we used to go to the library. There he cannot go to the other floors. 4 floors were there in the library. Many people remember on our library, fantastic library, our IIT library, where all the 4 floors I used to bring all the back references to him, and he put in a stack in front of a table, big table, I remember in front of my eyes, and every book he reads. So then you'll find, go and bring that. So I used to go to 4th floor, come here, 2nd floor, take all the books, put on his table. He marked one line. It's not a good habit, but still he has, many people remember, he put a vertical line and write VIP. VIP means very important point. So then after finishing everything, he will keep all the things to the students, and he will go, you read all the things, and let us discuss tomorrow. So they see kind of, when we read, we took so much time to read, but how fast he was reading the advanced journal, like he likes the most liking journal is Journal of Applied Mechanics, the Applied Mechanics Reviews. He liked these journals like anything. In fact, he told me that his entire PhD was based on only 4 publications that he submitted to IISc Bangalore, and he gave only a few linking lines between one publication to other publication, nothing else. He bound 4 publications and giving 1 page for linking the one publication to other publication. That's what he was seeing, the keenness of the research. So other than that, the kind of topic he chooses, he gives a lot of importance to the relevance of the project to the Indian context, beyond the research depth, state of art aspects. But he sees everything, but he has seen high relevance. For example, in my case, the viscoplastic simulation, we never heard about it when he told you take this topic. It took 3 months for us to finalize the topic, 3 months to finalize the topic itself. So once we have taken the topic, he has gone to so much depth and so much output has come, and several invitations came for making even IE, international, I think it's IE, that is Institute of Engineers, London, especially invited for writing a paper on this topic, the Sabosh model, the reduced Sabosh model something. So I am seeing the depth in which he has seen the topic. Afterwards, the relevance is very large on this topic. The GTRE, I think many people remember K. Ramachandra and S. Krishnan. So who invited to apply this, review their, the Kaveri engines based on the viscoplastic simulation. And then the scramjet engine by DRDL. I think Dr. S. Panneerselvam, yes, I think he was, visiting professor of IIT Madras. He no more, I'm sorry to say. And he invited to review the scramjet engine high temperature component based on the viscoplastic modeling. Then BHL R&D Trichy and BHL Haridwar. You see, the topic when you are chosen, gone to the depth to such extent, it never, very, very important. This is what I want to mention. And finally, I would like to say the last point about Professor Alvar, which is a bit sentimental. The last day, he told me, few days I was interacting with him. He told that, see, Chalapandi, you see the empirical approach is there, can be removed in engineering and technology. But I feel, his personal view is, empirical approach cannot be removed in medical field. Then I asked, sir, why you say that? See, Chalapandi, they're going on giving so much medicine. They are trying. And something working, something not working, again changing. Now I come to the situation that I never take any medicine from them. Then afterwards, after a few days, he is no more. See, what I want to say is that empirical approach has to be removed. It can be removed in engineering, but even the Professor Lakshman Rao used to say that. All his research simulation is you want to avoid empirical approach. That is the introduction he used to write. Why so much simulation, experimental, everything? It needs empirical approach has to be removed. This point I want to highlight it. And finally, I can say that he loves the students very much. He cares of the students very much. He read more than the students can be able to read. But what he wanted from the student is hard work and passion and dedication. I think other than that, he will never leave all of our hearts. He always lives. Thank you very much with this introduction. I thought I don't want to take more time. You can enjoy the lecture of another eminent Professor Jayan Reddy's this thing. Thank you very much.
Thank you, Professor Challapandi. So now I invite Professor Jayan Reddy for his lecture. Thank you.
Yeah, okay. So this is on, right? Yeah. Okay. You can hear me? Very good. Done? Okay. It's not, you have to switch. It's already connected. Okay, once again, good morning. It's really a pleasure to be back. So, since I'm from here, I don't know how many of you know, I went to primary, middle, and high school in Anamkonda. Okay? So, I will say, Endaro Mahanubhavulu, Andariki Vandanamulu. So, all of you know what that means, right? There are a lot of great people. To them, my pranams, namaskar. So I will start with that. And really, when I come to India, it is always very special moment in my life. Especially I'm old and becomes more sentimental, right? So, but my mission in life has been the same, which is creation and dissemination of knowledge. Sharing the knowledge. So my wife always asks, why are you traveling so much at this age? Because I don't want to kill my passion. That passion, once it goes out of your body, you die very fast. So you always have to have some passion. Okay? Whether watching the movie or cricket or playing golf, all of those are passions. But passions that really somehow make a difference in society. I think that is even bigger satisfaction. So with those few remarks, let me get to work here. So in the interest of time, I think we are running late. I will try to give the gist or main ideas of what we are doing here. So as many of you know, fracture mechanics is really outside the domain of continuum mechanics. So what I mean is, it does not allow you to have discontinuities. In fact, the very word continuum requires you to have a continuity of matter. The matter has to be distributed continuously so that we can take a limit in space. Delta x goes to 0. Should not land on a different planet, so to speak, right? Or different point. There should not be any gap. You should smoothly go from one geometric point to the other. So this requirement makes continuum mechanics not able to cope with the fracture. So what do we do? So engineers are problem-solving people. We don't sit there and say, oh, I can't do it. So we always say, I can do it. We find a way to do it. We have been doing that. So there are many approaches, and so we came up with an approach, and I'm putting the names in front of mine. Sachin Velayudan is a PhD student, and Professor Arun Srinivasa is my colleague. And this is where I want to bring Professor Alvar's name. Arun actually was a student in his class. When Alvar taught strength of materials, Mechanics of Materials course. He was in his class. So this morning I called Arun, he's in Texas, and I asked him about it. He said he inspired me. Inspired me to what I am today. So what most he can ask somebody like that? But he not only inspired Arun, many in his class. Arun had a very distinguished group of people. Mahadevan at MIT, and Kaushik Bhattacharya at Caltech. Arun is at Texas A&M, but he was top of the class, better than Kaushik Bhattacharya and Mahadevan. So don't underestimate the people just because they are less well-known schools. Okay? Texas A&M is a great school, great engineering school. In fact, we are ranked above Caltech in some areas. Okay, so let me not get into that. Let me talk about Alvar. I never met him, but I came to know about him through Arun Srinivasa. So he was very unassuming, humble, but yet very dedicated teacher. So I'm sure in his life he inspired many people like Arun Srinivasa. So that is one of the things that many of us really should do, especially in academic community. So legacy should not be about you. You should take pride in what we mentor and develop in the form of young people. So that is very, very important. So my sincere best regards to, of course, Professor Alvar. I'm sure he's looking from heaven. So the main thing that I want to talk about here, the roadmap, is just give a little bit of background motivation. Then I go to the graph-based finite element analysis. So you know every computational approach has so-called critical points, points that represent the continuum. And at these points, we relate the duality pairs, meaning cause and effect, like force causing the displacement, heat causing the temperature. So that is really what all numerical methods do. It sets up an equation like AX equal to B, where X is the dual to B. And this A is a matrix connecting the duality pairs. So I will get into a little bit more during this talk. And then we also, the latest work is about bending of plates. So in the past we have worked on elasticity, both 2 dimensions and 3 dimensions, in predicting the fracture in concrete and glass. And now we are trying to do the same thing with plates in the sense that there is a bending. And then next step, which is not here yet, is to do multi-phase materials like composites, which are much more challenging because of different kinds of modes of failure. All right, so let me say a few things about in the form of comment. See, it's very deep subject, and so, I don't want to show off here, so to speak, but I want to encourage or make you feel that, oh, there is something I can do. Follow up. So we have the software which we can share. Okay, so all you need to do is ask and use it. And if you don't understand, you just let us know. And we have also prepared a guide so that you can take it and run with it. Okay, so very first thing is to understand that micro cracking in materials is very common. Whether it's composites, concrete is a composite. And when we talk about micro, really we cannot see with the naked eye. So they are there. So we may call it damage, but they coalesce during the service condition while doing their functionalities, and then they become cracks that you can see with the naked eye. So that is a very important problem, because once it develops this damage and coalesces, then the functionalities may be compromised. So we need to know in some way what is the residual strength or ability to function. So in general words. So hence accurate and reliable modeling of fracture in materials is very important. And especially constitutive models that dictate the prediction of failure. See, most important thing that we all should understand, it is not the deterministic path of the crack. It is the probability of failure. Because designers don't look for deterministic things. The band in which it is going to operate is what they are looking for. Okay? So we really should pay attention to the probability of failure rather than accurate. So even before people talked about the deformation, they are more interested in failure. Way back, if we go to the Leonardo da Vinci, Italian, and so and also Galileo, both of them, they said among chords of equal thickness, the largest is the least strong. And many of you know from strength of materials, the deflection is proportional to the length cube if it is point load. If it is distributed load, it's length to the power 4, right? So that means longer it is going to have large deflection which can cause other problems including failure. And the second thing that as the length of the beam increases, its strength decreases. And both of them kind of alluding to the same fact that the weakening of a structure is connected to geometric dimensions in addition to material properties. So look at the glass. And so the tempered glass exhibits different fracture phenomena than untempered. So most of our automobile windshield is tempered glass. If it is not, it's dangerous. If a stone hits, nobody has to attack you. Just another vehicle going next door, next lane, can make a rock come and hit your windshield. This happens a lot in Texas, by the way, because we have a lot of trucks. Okay? It happened to my car several times. So fortunately, the windshield doesn't break into what is shown on the left. Okay? So you can see this. And so this, once it is loose, it can fly and actually penetrate into your body, right? So whereas it does this, so nicely it comes down. Okay? So, but the point I'm trying to make, all of the existing techniques, such as the extended finite element method, XFEM, cohesive zone model, and even phase field, all of these, and peridynamics, the new kid on the block, all of these can only address single or multiple cracks. But if you have hundreds of cracks, they don't know how to do. Because you have to put hundreds of cohesive zone elements, and you don't know where to put them. So XFEM is the same thing. That means half of the answer to the problem must be known even before you apply them. So that's not realistic. So we need to find a way to model, and this is a continuous thing, and somebody after me will come and say, I can do better than what Jay and Reddy did. That's what I like. Because I don't want to remain as a person, but I want my work to inspire other people to do better. So there are obvious challenges. This I said to start with. When fracture develops, an interior point becomes a boundary point. And this is not allowed in continuum mechanics. So how do we get around it as engineers is to discontinuous fields. That's what XFEM does. Or use discrete models, numerical techniques, such as cohesive zone model or lattice bond breakage. Okay, so, and everything we do is a model. So this is my statement. A lot of times people think that continuum mechanics is exact science. It's not. The physical laws are also, just like many civilian codes are interpreted by supreme courts of each country, there are interpretation of, that means what do you include in saying. For example, the Newton's second law of motion, what does it say? The total time rate of change of linear momentum is equal to sum of the forces. It's a very generic statement. Then you have to identify what are these forces. Short forces, long range forces, magnetic forces, right? There are a lot of things. So to quantify that statement, we only take some parts of it that we understand and put it there. So the quantified equation is a model. Model to the extent you understand it. There may be a lot of other things happening. There may be other kinds of forces or stimuli. So what I'm trying to say is everything that we do is really modeling, representation of the physics to the extent we understand it. So there is no exact solution or no exact mathematical model to anything that we deal with. But that does not discourage us. We continue to improve. That is what research is all about. Okay? All right, so let me say that simulation of fracture has gone into two different ways in last several decades. One is continuum-based models. That's where the linear elastic fracture mechanics, continuum damage mechanics, extended FEM, all of those came, even including the phase field. Now then there is second category called lattice models, cohesive zone models, peridynamics, all of these ultimately breaking the bond between 2 points. So each one has its own merit, but we want to do both. That means we want to solve problems that are continuum type, but they develop discontinuities because of damage and fracture. And then bond breakage is very good, because all you need to tell whether the distance between 2 points, and that distance is going to be changed because of the force acting between them is discontinued because of a crack, breaking that bond. So we want to bring both of them into the model, and that gave rise to the approach that we are talking about. So let me go and kind of review shortly or briefly this linear elastic fracture mechanics. It really addresses one single crack. Okay? So if you have a couple of them, it is really very hard to do it, especially crack closure. And many of these methods, they are not able to do crack closure. Because if two cracks that are perpendicular to each other, while one is propagating, other may be trying to close. By the way, I'm not saying it is going to bond back. That doesn't happen. But closure is real, right? So CZM, the cohesive zone models, XFEM, all of these deal with few cracks. And when you go into many cracks, then you have to talk about bond breakage. And so especially if it has millions of cracks, continuum damage mechanics or diffuse damage is the other extreme. So all of these have to be accounted. And of course, if you are only interested in 1 or 2 cracks, you can remain in that area. But if you have many, many cracks, especially as seen, whenever you see concrete, where slab is poured after it settles, you can see a lot of micro cracks. Okay? So that's the reality. So we have to address how to take care of them. All right, so I don't want to read any of these, but I listed different methods and what are the issues with them. And so none of these are able to do every one of the problems I listed in the previous slide. So how do we deal with the geometry of fracture? Okay? So we will use the concept from graph theory. So graph means, really, as engineers, graph is to plot points, right? Okay, so the same thing in the case of discrete structure, you identify points. In finite elements, they are nothing but nodes of the mesh. So by connecting those nodes, you're creating elements. But what we have done, traditionally, every time we wanted to compute stress, we use the nodal values to come up with the displacement function, then differentiate it, get the strains, then multiply with the material constants to get the stress. Where? At Gauss points, interior of the element. And then if a Gauss point experiences a threshold, exceeds the allowable, then we declare that element failed. So this is very, broad brush. So what we did, accidentally, I and Arun Srinivasa wrote a paper without thinking fracture. Oh, why don't we actually calculate the forces and strains along the edges of the element? Okay, think of triangle. So, along the sides of the triangle. We can do it, right? We can write along any line if you want. So, then it occurred to us, if I know that force along 2, I can also check if that force exceeded the value. This is very similar to bond breakage. Okay? And there is no element deletion here. So once that is broken, only that side, the stiffness won't come into picture, but still element is connecting to other sides. Okay? So we continue to do this, and that is how we got into. And second, how do we deal with the physics of the fracture propagation? So we discretize first. That means we create the finite element mesh. So there are no new finite elements in our work. Same old, whatever you want to use, quadrilaterals, triangles, anything, tetrahedron in 3D, that's fine. And then we apply the selective non-locality. So this is what is new with our work. So we bring non-locality. Peridynamics is all non-local. There is no such thing as everything non-local. There are only hot spots in a structure that experiences large gradients. Not everywhere, right? So non-local discretization of a body is not good. You should only do locally. So we have continuum that takes care of the every place. And when there is a high stress concentration locations, then we bring the non-local. What that means? We are saying stress at a point is not only function of the strain at that point, but strains many points around that point, neighbors. Okay? So we use that concept, and then we say what is the region size? And that is of course debatable, but common sense tells you it should include at least minimum the grain size of that material, right? Whether it's a glass or concrete. So average grain size can dictate the radius of the circle in 2D or sphere in 3D. So within that there would be many, many elements. So we average all of the strains of those. And this averaging many and summation is integral. So that is the non-local integral of the strain. So that's what we do. And when the strain or force, you have the freedom to choose the criteria, strain criteria or stress criteria, then we say it's broken. So take a triangle. So how many ways you can think of breaking? Because there are 3 sides, there has to be 3 planes. So that's the minimum. So, but that's how we started. But then said, oh, why not create many planes? So somebody like Bazant, Northwestern, is very, very famous person. He was with me 2 months ago to discuss. So he uses 32 planes. So we quizzed him. He says, I don't know J and Y, but that's how it works. So, but we have much more physical reasoning. So we use 3 minimum for the 2D, 6 minimum for 3D, right? And then we said, okay, let's start using more planes, see if it makes a difference. And we found it does make a change, but it's not significant from engineering point of view. So it settles. That means we are able to predict the maximum load it carries, no matter how many planes you use. Of course, starting with the minimum 3 in 2D, minimum 6 in 3D. Okay, again, in the interest of these things, so I started with these points and connect them. This is the graph, but that graph is nothing but a mesh of finite elements. And another very important thing in our work, we give lot of value to duality. So actually duality plays a great role. Some people don't recognize it. That's what it is. Finite elements is about duality. But in the books they don't mention too much. But structural mechanics people are more conscious about it. Because there is always cause and effect. One causes other. You cannot ask for both to be determined. You have to know one and determine the other. Okay? So that is how the reality is. So we say the primary variable, such as displacement, lives on the primal mesh, which is shown here. Okay? Whereas these dual variables live on a dual mesh, which is really nothing but Voronoi diagrams for the given structure. That means you create by cutting through these edges, you come up with another polygon, and that is where, along this boundary of the polygon, that's how the fracture propagates. That's our idea. So, like XFEM, it thinks that crack is going to be between the two element interface. In our case, it's cutting the edges. Okay? Of course, it is zigzag, but it is, for a naked eye, once you plot, it's not zigzag, because the mesh is so refined. Okay? All right? So, anyway, this is the paper I was saying, and that what led to all these later developments. All right, so I won't go into all the details here, but the fracture modeling in the case of plate bending, that is the latest work I want to share with you. So 3D finite element analysis of plate and shell structures is no, because it's computationally very intensive, independent of fracture mechanics, by the way. So, for example, if somebody models automobile structure, body, they don't use 3D elements. Maybe for piston rod, they may use 3D elements. So, because we have very powerful plate and shell elements in abacus or ANSYS, wherever it is, and it is much more economic, computationally speaking, right? So, and when you think about plate and shells, you really think of plate and shell theories instead of 3D elasticity. That's what I'm trying to say. So we bring that into fracture modeling using the first order shear deformation kinematics. And those who know a little bit more understand the phrase. That means we account for the transfer shear strengths also, which is not common in the traditional or classical plate and shell theories. So we developed the model that could predict the structural response of brittle and quasi-brittle materials at very different loading conditions, even including the strain rates. Okay? So we actually do dynamic analysis, impact. Okay? So you will have an additional lecture tomorrow on that kind of thing. So the key features are finite number of crack planes at both faces. So you know when you do impact on say a plate, the crack actually develops at the bottom first, not on the top. So we model both surfaces. So but plate and shell theories, only mid-surface is the real action. So but we created a mechanism to study what is happening at the top and at the bottom, two surfaces. Okay? I mean actual test you do physically. It's a drop test, a spear dropping on a plate. So it actually develops crack, initiates at the bottom, and then of course propagates through thickness to the top also. So it is three-dimensional in terms of actual thing. But in the interest of computation and also ability to see what is happening at the top and bottom, we were able to accomplish that through the crack planes. And so two internal variables are micro crack growth and coalescence. Okay, so this is a kinematic quantity. All right, so we also have equivalent crack opening displacement. When I use the word equivalent means it's integrated value. And so linear elastic response based on tensorial strain. Well, okay, so this is what I'm just showing. If you think of a typical asbestos or some, what is it, plaster of Paris plate, after it is made, you can see typical cracks. Okay? All right? So we create these planes, and as I said before, if it is 2D, we use minimum 3. But here we are using multiple, even to see if it makes a difference. All right? So then we define, as you know, in continuum mechanics, area is not treated as a scalar. We treat it as a vector. The vector, the magnitude is the area magnitude, and the direction is the normal to the plane. Because this really helps us in a lot of ways analytically writing the equations. So we use that concept here. So the crack plane, CP, is here red. It's normally shown here. And of course it will have the components. The normal will have X and Y components. And so they're a little bit deep here, but I want you to get the general idea. So we start with the shear deformation theory shown on the screen, where we have rotation functions Rx and Ry. Rx is the rotation about the y-axis, and Ry is the rotation about the x-axis. Okay? So you might think, oh, why do you put the different subscript? Only because it appears in the x component of displacement, we put x. But the rotation is about y-axis. Okay, so, and you can see cracks can develop at the bottom or top depending on, initiation, depending upon how you are bending the plate. Okay, right? So tension is what causes the crack opening. So when you bend convex up, so crack is going to be at the top first before it is at the bottom. So, and if it is stretching, of course, it uniformly shows up. So then we really, this is where a lot of non-locality is brought in. So this is a little bit of deeper subject, but I'm trying to avoid discussing the detail. But most important of this is integration of the strains within that sphere or circle, and also bring the probability function. So you can see that phi is this is not like a phase field phi. It is physically, it's an indicator whether, if it is 0, that means crack has opened. If it is 1, the material is intact. Okay? So that is the idea. And then we go on to define the Helmholtz potential in terms of the strains. You can see that. And in the case of the plates, you will have in-plane force resultants and also bending at force resultants. And so again, it doesn't make any sense for you looking at the slide, so just understand the general idea, okay? Because there is a lot of things that you need to read to go somewhere with it. So this is where the non-local strain. You can see anytime you see integral statement means it is a summation. And you see some features that you would see in bond breakage or even peridynamics. If you are at a point X, any other point around it is Y, and we are saying the distance is what we measure. And that length in 3D, if it is going to break geometrically, that is how the strain is created. Okay? That means change in the length, right? That's what our strength of materials thinking of a definition of a strain. And so anyway, this model, our model requires 7 parameters as opposed to some 32 or 37 parameters in Bazant or other people. So many of them are very physical, and the other are a little bit mathematical in this. So this is like Young's modulus, shear modulus, Poisson's ratio. This RP is the radius of the circle in 2D. It is the radius in 3D of a sphere. So this is a parameter that you have to choose. How do we choose? As I said before, it is the average grain size. If it is a crack in a concrete, what is the average grain size of the concrete? So that is how, or if you want to use stress intensity factor for that radius, that's okay too. Okay? So we have done that also in some problems when we didn't know the grain size. All right? So, sometimes it's all just, I'm explaining different things. because these are introduced in the non-local model that we introduced. So you can see the critical tensile strain rate. Power law coefficient in the power law that we introduced in the thermodynamic context. This is the threshold for the tensile strain. Okay? So in fracturing kinetics controller is this G0. I said shear modulus like thing. All right? So then finite element implementation. This is another very nice thing. We did not write another code ourselves. We created VMAT. So everything is, we are making use all the finite element technology, mesh generation, mesh refinements, solution of equations, post computation, everything is there in commercial code. So we exploit that. And we do all this non-locality through VMAT. And we can give you that VMAT. That's what I'm saying. So we have created a user's manual. So and I have it in my computer that I can send it to anyone. And so of course what we expect from you are two. One, acknowledge if you do some work. That's the fair thing. Respect each other. Don't steal from each other, right? The second is tell your experience so that we learn. Just like all these softwares, one day they start freebies. Once you hook to it, then they start charging, right? So we are not going to charge, okay? That is a promise. But we want to learn from your experience and see if we can improve. Okay, that's the value we get from you. And of course, the rest of things. Oh, one more thing I forgot to mention. We also have a collaboration with Prakash Tamburaja from National University of Malaysia. So he spends time with me every year in summers. He was a former student of Lalit Anand from MIT. So he's very good at the abacus implementation. See, we all have to, this is where collaborations help. Having deep knowledge about mechanics is not enough. You have to implement, you have to translate that into computational algorithm. Okay? That means you have to have also good ability to translate into numerics. Okay, so there are many numerical examples, and this is a list of few papers. Most recent are, you can see from the last two, Extreme Mechanics Letters, Journal of Mechanics and Physics of Solids, and another paper is, really two papers are in works on the work that I am presenting here, and we don't know where they will go. So you remember that 7 parameters, first you have to calibrate. That is where we use the experimental. So you will see a lot of experimental comparison. I'm not going to compare with peridynamics or phase field because they're all numerical. See, that does not validate my work. So I have to compare with the experiments and use experiments to extract these 7 parameters. Okay? So this is a dent response of plane dent, okay, impact. So we first use one of the experimental, one of the experiments. By the way, a paper can have more than one experiment reported. So we use one of the experiment to extract that. Then we predict the results of other experiments that are reported in that same paper. That means we don't validate every time. Then it's cheating, right? Because I'm just using that to get my parameters and show. That's not great. So only one experiment is used to extract the parameters. Then we use the same parameters without change and predict for other strain rates, even 2 orders of magnitude difference. So this is what we really started feeling good, that we have something really worth sharing with others. Okay, so you see that there are many things that you don't have to read everything. There are different number of crack planes. CP is a crack plane. So what you see over many of these, all of the curves, many curves. And now if you are a really theoretician, you always look at how much difference. For a practical purpose, all of them are all same. No big deal. See, real world is not looking for exact thing because there is no such thing as exact. There are a lot of ignorance because we don't know everything, right? Materials are very, very complicated. Same specimen made by same company is not going to be identical to the, when it comes to fracture. Any minute, small, micro thing can change the trigger, different cracking. So it's a waste of time to really focus on the exact thing. So you look at these and say, oh, they are very good. So that is how we take satisfaction. So we have done many examples, and we even went on to compare, in some cases, just to tell people how good it is. And this is one of those to get a mixed cracking. And so you can see, when you see this, these are support. And then if you apply loads, and it is going to create a crack here, and it will propagate. By the way, the method does not need a crack to start with. It can predict initiation, propagation, branching, and also closure. So that is, I think, is very exciting. Okay? So this is one of those, think of concrete block which is fixed here, and now you are pushing here. So you know crack will initiate there. So this is a more or less engineering intuition, right? So all you do is create a little bit more dense mesh without knowing which way it is going to go, right? See, this is where cohesive zone model needs a little bit more help. Where is it going? So that I plant the elements. Here I don't need to do. Only thing I need to know is where it is going to initiate. That is where our engineering intuition tells you it will start somewhere here. Whether it goes this way, this way, this way, all of that is going to be done by the physics. Okay, so you can see different paths, and so this is the experimental. Of course, I'm showing the band because they did many different experiments for the same thing. They repeat it, and they won't be exactly the same. So there is a band. That's what I was alluding to earlier. So our results are right here. After we obtained with one of the experiments, okay, and which is not shown here, but that it will be very, very good fit. But once you go to other examples, of course there is a deviation, but you can see qualitatively very, very close. And especially when you see this maximum is almost close to what is experimentally observed. So what is not known to the theoretical people, computational people, is these micro level defects in the material. Experiments will see it, but I don't know what that is to be able to put it there, right? I can always manipulate those parameters and duplicate those results, but that's not my purpose, okay? So you can see that that is actually cracking, experimentally, and of course phase field people might be able to say, I can do it, okay, all right? All right, so we started doing our own experiments. Okay, I'm not an experimentalist, Arun is not. So, but we thought, oh, not a big deal to create a simple experiment, tabletop. So what we did, as you can see in our lab, this is a hollow cylindrical tube. Then the iron ball is guided when you drop. And this is the plaster of Paris disc. Okay, and of course there is another one we place only to create a little bit of compliance. Okay, otherwise the hard one will aid the cracking, right? So we want to study that also. So when we do FPM, we put everything into the model. Okay, of course this is treated as rigid, the ball, and this is the actual, the disc is here, and this is the cushion, and the rest of it supporting platform is also there. So we have done, and we compared these results with, those are the results at different velocities. You can see top is here, bottom is here. So you can see it really starts at the bottom more before you see at the top. See, it starts in the bottom, nothing here at the top. So as you go more and more at the bottom, and then it starts showing at the top. Okay, so, and of course you will see that, but you can see they're all kind of predicting similar valleys and mountains. And so, and these are different sets of number of crack planes we have used. And this is the three-dimensional view of the how it crack is. See, it started, I'm not showing bottom, but it's showing how it's propagating from the bottom to the top. So, Pani, you have to tell me when to quit, okay? You have to, because I don't want to. So this is another one. We also do viscoelastic material. So this is a plate with a hole. We are using half of it and subjected to pores, tensile pores. We use different kind of meshes, coarse, medium, fine, and very fine. So you can see all of them more or less there. See, that tells us that even the so-called coarse, of course, coarse is also a relative word. How many elements? There may be still thousands of elements. And by the time we come here, it runs into million, very fine, okay? So this gives you a feeling that we have a method that basically converged. So there is no more mesh dependency. And this is another important thing. There are no existing methods that have this property. They are not mesh independent. Results, as you refine the mesh, they keep changing. And we found after all of this, non-locality concept is necessary to remove the mesh dependency. Without that, it will depend. Okay, so this is a picture. It will show for the very slow deformation. And you have to have patience by the time. Now you can see how it is tearing up. Okay? And if you go to little fast, next slide, and it will take a while to start, but once it starts, it zips through. So you can see a little bit of this zigzag. You know why that is, right? We have elements. It's only cutting through the edges, not along the... So I'm not putting line up the interface. So the elements are being cut. The edges are being cut. So there would be always that zigzag. Okay? And this is the computational. All right. So now let me go to another slide. So this is what you see for different speeds. You can see they're listed here. Okay, so we also studied delamination, peeling from hard, substrate. Okay, so it's like you put a tape and you pulling. Okay, there's a scotch tape or tape that is, you bonded to the floor for whatever reason, and if you're peeling, and we can study that also. And so we were able to predict it, and XFEM could not even converge. So you can see that, what XFEM is doing here. You see this? So this is our result. And you will keep seeing there are a lot of other interesting things. If you study a material, and this is really one of the things that we will use when we go to composites. So matrix and then a fiber. So when crack initiates, for example, at 1, and then it goes, and if it is XFEM or cohesive zone model, it will stop here, and because it doesn't know where to go. So whereas ours, it zips through, because it does not penetrate the fiber, which is very stiff. Okay? So this is a very, very interesting observation. You can see that XFEM stops there. So ours, whereas it goes through, and so of course the results for maximum, value is same, which is a good thing to know. So now I want to show some results of the plate bending. See, all of those are elasticity. Okay, you're really talking about applying loads in the plane. Okay, so here we are applying the loads transverse to it. This is a circular plate. and it is supported at the edges, and then we are pushing again a circumferential, what happened, something. Oh, sorry, what was that sound? Okay, all right, thank you. Okay, so this is the, what we call line load, pushing. So you can see how the cracks develop. By the way, these are experimental. We are trying to duplicate these results, and of course you won't get exactly same, but you will see qualitatively very similar. You can see these are our Grappia results, and these are the experimental. I believe these are from Bazant's group. Bazant does mostly experiments, but sometimes he uses the computational, and that's where he has these 36 planes to model. So you can see different average survival probability of evolution at the bottom surface of the plate. So this is a very interesting phrase, because we only say it's not a crack, it's survival probability of something getting broken. That's how we phrase it. Okay, we also did this triangular plate with 3 supports at the bottom and then impact from the top. And again, you see the experimental results, not our experiments, and those are the Grappia results. So you can see it's kind of predicting what you see here. And this is maybe the last one. The glass is very interesting, right? If you impact, it has a radial cracks and then also creates circumferential cracks. So predicting this using any of the existing, whether it's a cohesive zone model or peridynamics or phase field, it's very difficult. They cannot. I have not seen any of those people predicting. So those are our Grappia results. Okay? So then you say, oh, really getting exactly same. As I told you, I cannot talk to the material, right? The material has its own flaws or micro damage. Unless I know, I cannot put it into the model. So we can only look at it and say, oh, we are close. And that is what designer is looking for. Are you in the ballpark? Okay? All right, so I think I need to move on. There are many other things. In all of the cases I'm comparing here, it's all theoretical now. There's no experimental here. I'm showing top and bottom. And they Grappia 3D and versus Grappia 2D. Okay, so this is important. We have the ability to do 3D, although I claim that it's too expensive. But we have to do 3D also to make sure our 2D is doing reasonable job. Plate bending theory, first order shear deformation theory. So it is very nice to see 3D and 2D predict the largest load very accurately. And the loading part is very almost on the top of each other. Unloading is slightly different. So you know the difference between 3D and 2D. 3D sees the crack as a surface through the thickness. 2D does not, because 2D is just a plate or shell theories are just mid-plane. So you only do post-computation to see through thickness, because post-computation in plate and shell theories allows you to go through and compute the strains at any thickness point also. So we did cantilever plate, same thing. Results are very good, promising. And that is the last one, circular plate. So I'm rushing a little bit, but anyway. So the summary is, I don't want you to read it, but our goal has been develop thermodynamically consistent. So when I put that word, some people really get bothered because I'm criticizing them, including Bazant. Bazant is a very straight shooter. He tells in his papers, not only in meetings, that he doesn't understand, if he doesn't understand. Or he will say that I do this, but some intuition, but I cannot explain. So at least he admits, right? So thermodynamic consistency has to follow the laws of physics. That's what it is. So when you violate, for example, take phase field. I'm sure some of you doing it. It's not a criticism, but an observation. So what is the phase field parameter, physical meaning? I asked several people. Suddenly they get caught. I said, oh, I don't know. Maybe it is the number of particles that are separating. So, I mean, it's very, so it is just happened to be a parameter in the model. That's it. No physical meaning. And they say they're minimizing. How can you minimize something irreversible? You see what I'm saying? It cannot undo. It can only do. Right? So it cannot close something. So what I'm saying, there are thermodynamic issues with a lot of these things. So anyway, the purpose is not to criticize them. How do we better it? That's what our goal is. So that's what we are trying to do. So, and we have done many, many examples involving plain concrete and plaster of Paris discs. So we really quantified accurately through our Graphia's finite element simulations. And these developed plate-based, first order shear deformation-based Graphia results also very promising because we kind of validated against our own 3D simulations. Okay, so this last slide is a way connects back to when I started this talk. So two bullets are very technical. So we must develop robust computational tools. Word robust means no turning the knob or fixing. That means there should not be ad hoc things in there. Okay? It should be consistent with laws of physics. If we cannot do it, of course we invented these tricks. That's engineering. We always make assumptions. But we should really focus or put effort, slowly remove those fixes and knobs by understanding, gaining insight into what is happening. Okay, why computations is important? Because any experiment you want to do takes time, cost. And every time you have a crank idea, what if I change this little bit? Then you have to go buy another equipment and install and test, right? Whereas with the computation, we can, middle of the night, you get an idea while thinking about something, work, right? This happens to me. And suddenly you get up, go sit at the table, try, right? See, this is the power of the computational tool. So, unfortunately, the power of the computational tools misinterpreted by community that supports funding. One time Rajendran was there like giving money, but now he's begging too, like me, right? So what I'm saying is they think all the mechanics is in abacus and ANSYS. They don't realize abacus and ANSYS has the mechanics that was some years ago. It needs to be improved. Like plate and shell elements are not foolproof. See, that is another area I work. So I developed an element that doesn't have reduced integration. No tricks. It does not lock. Okay? So this, when it has to get into the commercial environment, that's where they should put effort. And of course they will. But they always depend on the clients. If there are not enough number of clients asking for it, they won't do it. Why do it? Why waste their revenue on it? Okay? So we keep doing our work and let them come and use it. So this is the continuous collaboration between the academics, R&D, and industry. And the vendors, computational software vendors actually have to, they pay attention to the people from industry. Because those are the people who are asking, they are the people giving the money, not the academic people. Academic licenses are very cheap. All right? So the second is we must conduct experiments. So I was not trying to say experiments are not important. So, but we can only do few, so, but we have to do those right ones. Because we have to make these people here honest. They cannot just predict whatever they want. So the experimental people keep you honest by saying, oh no, your results are wrong. That's not what we see. So we need them. There is no question. The next two bullets are really, I like to say, I said that already. So we are not Einsteins. We are all ordinary people with ordinary average intelligence. That includes me for sure. So, but we advance the science and technology incrementally, but together significantly. That's how the society benefits. Okay? Thinking about my study here, forget about computers. I didn't even have a calculator when I was going to school. What did I use? Slide rule. I still have one of them. Slide rule. And they allowed slide rule into exam hall. Okay? So now there are a lot of things. Now people can write papers using AI. ChatGPT, right? Okay? It's good to have those facilities, but don't depend on them too much. Okay? You should be yourself. Getting help is fine, but don't become a slave to them, because they can only do what the data is in the, so, but we have to keep creating the data. The data science requires data. Unfortunately, data is not there enough in the technical area. Why? There are fewer experimentalists. It takes a lot of time for them to publish. Unfortunately, our administrators want more papers. Why? So, and the experimental people need more money than somebody like me. All I need is to pay the graduate students. Computers are so cheap. But the experimentalists not only have to pay the graduate students, but they have to pay for the equipment and the material costs. And it takes time to publish. So the data is limited. And second reason why it is limited, most of the data is created in the industry. They are the one doing a lot of experiments, but it's proprietary, they don't share. So where do you get data? Top bullet. Data is going to come from computations. And the data has to be certified by mechanics principles. And the mechanics principles are there. Right? So this is why I say we have to take pride in whatever little we do without depending on these artificial tools. We make use of them, but don't become slave. The last one, I want to kind of urge senior faculty, senior supervisors, seniors anywhere, industry, R&D, we really have to show interest. We compete, by the way. We compete. Okay? A professor may be competing with an associate professor. That's normal. But that should not prevent you from advising associate professor what they should do, what they should not do, whether it's in a classroom or funding or doing research, right? Because we have to be a little bit more open-minded about it. Competition is everywhere in the world. Everybody working in industry, they know. Only one of them would have a chance to be promoted, because there are only few jobs in the next level. So, but we should not stop from advising, mentoring, developing them. So with that, I take, and just request you that please pay attention to the last bullet. So here is my family. By the way, the two people, just me without my new face and my wife, the remaining three are my grandchildren. So you don't see my children. Okay, they already told me, bye-bye, Dad. Okay, but now my grandchildren, before they say bye-bye, Tataya, I want to enjoy them. Okay, so enjoy life without worrying about this warranty period. The good thing is many products have the warranty written on it, but it's not written on my face. So I'm going to live as if I'm going to live forever. Okay? Thank you.
Yeah.
And
Thank you, Professor Jain Reddy, for your, first of all, for your, from US, to here, coming here and giving a, very vibrant lecture on mechanics. Of course, with Professor Reddy last year, he was here. This is the 4th or 5th time I was meeting him since 30 years. Because we always call him like, young dynamic man of 50 years of expertise. So always when you talk to him, you can gain a lot of knowledge, even because he'll be here for the three days. So you can talk to him not only technical things but many other things, because he was roaming all over the world for many years. So we are very thankful to you, sir, for again coming here and for accepting our request and for giving this presentation. So hope you will have a interaction with him, after this. So with a big round of applause, let us thank him once again.
So I will be around, so you can ask me, I'll talk to you. So this is one of the reasons why I come. I mean, not only to India, anywhere. By the way, on this trip, I've been already in 3 different countries. Okay, I was in Spain and in France, and then of course in Bangalore, visiting Indian Institute of Science. So now I'm here. So really my passion is, as I said at the very beginning, is to talk to people, especially young people who want to learn. So, all right, thank you.
Thank you, sir. Thank you very much. After this, we'll start our actual sessions in the seminar hall complex, which is just diagonally opposite to the auditorium. But before that, there are 2 things pending, and we're also sorry for, little delay. So anyway, for the first day, it will happen sometimes.
So take my power.
So actually, what we do is first we'll go for a photograph, just after this door. And after that, high tea is arranged just this side, so you can come from the other side, okay? So once we finish high tea, we'll go to the seminar hall complex, which is just diagonally opposite to that building, okay? So we have 5 conference halls there, 6 conference halls, so all the sessions will be happening there. So all conference participants, and we also have a parallel mini symposia, so mini symposia participants, as well as the undergraduate research presentations are there, URP program, so all can go there. So our student volunteers are there, they will guide you. Okay? Thank you very much. So if you have any questions, you can ask one of us or any of our organizing committee. Thank you very much.